Greetings, my tech friends. In this video, we'll discuss 5 Prometheus sample questions and demonstrate them collectively within a single lab. For the lab documents and code, see the GitHub link in the description. Also see the description to get your free Prometheus Cram Sheet and 5 more sample questions. Let's go. You have downloaded the Prometheus binary archive for Linux. After extracting it, which command correctly starts the Prometheus server with the default configuration file? Is it A, sudo systemctl start Prometheus, or B, /prometheus --config.file equals prometheus.yaml, C, prometheus install --default, or D, sudo apt-get start Prometheus? I'll give you 3 seconds to pause the video and think about your answer starting now. And the correct answer is B, /prometheus --config.file equals prometheus.yaml. After extracting the Prometheus binary, you run it directly with the /prometheus command. And then by default, it'll run the file called prometheus.yaml if that exists in the same directory as your Prometheus binary. But maybe you have a different name for your config file. Maybe it's located somewhere else. You would use the --config.file flag to specify where it is and what the name of it is. But if you ran it this way, it would just run Prometheus normally. The key element in the question is which command correctly starts the Prometheus server. That's what we want. And with the default configuration file, which would be prometheus.yaml by default. All right, so let's start the lab here. And we're going to show the Prometheus binary install. And we get that from prometheus.io/download. So I've set up 2 virtual machines to get this rolling. And again, the lab is in a repository on GitHub. The link for that is in the description for this video. And so here's my first virtual machine. This is a Debian system. I'm going to go to my Firefox browser, but we're going to get out of here and go to prometheus.io/download. And once there, if we scroll down here, you'll see some downloads for Prometheus. We have Darwin for macOS, we have Windows, and we have Linux. That's what I want. If you want other platforms or other architectures, you can go to the GitHub directory here at Prometheus/Prometheus. So I'm going to right click on the Linux tar file and select copy link. Then we'll open up a terminal. Okay, and this is my system I'm working at. This will be my Prometheus server, and it's known as Deb1, and I'm just working as the Dave user account. But we're going to take that file, we're going to do a wget and paste that in here. And that should download it for us. Very good. So if we do an ls, we'll see Prometheus 3.13.1. As of the recording of this video, that's the latest version that they've come out with. So we'll use that. All right, so we need to untar that. So we'll do a tar and xvf on that file. Okay, good. And we'll change over to that new directory that's created. And inside there, you'll see a license, a notice. You'll see the Prometheus binary. That is the executable that we run. Then we see the default configuration file, prometheus.yaml, and also the prom tool for analysis of our Prometheus server and our config files. Very good. Now let's go ahead and run it. I'll go to the top of the screen here. And to run it, it's just going to be /Prometheus. And that exists right here in this directory. So we'll do it with the /. And we'll say --config.file equals prometheus.yaml. And that's YML. Now, do we need all this? No, because prometheus.yaml exists right within this directory. So not really necessary, but just showing it for good measure. And if we press enter now, Prometheus will run. Now, this is running in the foreground of this terminal. If I wanted to do anything else with this system, I would have to run another terminal. Now, normally in the field, you would run Prometheus as a service, and I show how to do that in the video course, but here we're just keeping it simple, so you can just download the binary quickly and run it. Now let's verify that Prometheus is running, and we'll do that within our browser. We'll open up a new tab, and we'll go to http:// the localhost, this system, :9090, because that's the port that Prometheus runs on by default. So localhost :9090, and we are in. Here is the Prometheus web UI, otherwise known as the expression builder. And we put our expressions right here to do PromQL queries against the Prometheus server. There you go. So it is installed and working and running, and we can access the web UI. Very good. Now, it's always good to know the correct answer and know how it works, but it's also a good idea to know why the incorrect answers are incorrect. So let's take a look at those. Answer A says sudo systemctl start Prometheus. That's only going to work if Prometheus is installed and managed as a systemd service. And like I say, that's how you would normally do it in the field, but that's not what we did here, and that's not what they're saying in the question. This is a binary archive, a binary install. We're running right off of that binary. So A is incorrect. C says Prometheus install --default. That is not a default Prometheus command. And D says sudo apt-get start Prometheus. Apt-get is a package manager that's not used to start services. You would do something like this command. And this is something that you would use in the field because you'd be running Prometheus as a service. Very good. One question down. Excellent work. Let's continue. Here's question 2. You have installed and started Node Exporter on a Linux system. Which entry in Prometheus.yaml correctly configures Prometheus to scrape it? A. Targets localhost 9090. B. Targets localhost 9100. C. Targets localhost 9093. Or D. Targets localhost 8080. Feel free to pause the video, and I'll be back in 3 seconds with the correct answer. And the correct answer is B. Targets localhost and port 9100. Port 9100 is what the Node Exporter listens on by default on HTTP, right? Port 9090, that's the Prometheus server itself. 9093 is used for Alertmanager, and 8080 is not a standard Prometheus ecosystem port. All right. Key elements in the question: Node Exporter, which we know uses 9100, and also entry in Prometheus.yaml, because you need to add targets in the Prometheus server so that it can go out and scrape information from the remote system that's running the Node Exporter. So that's what we're going to do. We're going to continue with the lab and install the Node Exporter on that second system. Okay, so I'm at my second virtual machine, and I've already gone to prometheus.io/download, and you'll see up here we have a lot of links for stuff that you're going to use quite often with Prometheus, and here is Node Exporter, so we can click on that to jump right to that. Make this a little bit bigger, and so here is the Node Exporter, and we have it for macOS and we have it for Linux. Now, you can get other exporters for other OSs and other types of systems and programs, but these are pretty much the most common you're going to use, especially the Linux one. So that's the one I want to grab. I'm going to right-click that and copy that link. And we'll open up a terminal on this system. Now, for my second system, the system to be monitored, it's called Deb2, and I have a light-colored background here in the terminal. All right, so let's do a wget and paste in that link, and we'll download the Node Exporter, run an ls, and here is the tar file. Once again, just like with the Prometheus installation, we need to untar that, so we'll do a tar xvf against Node Exporter, okay, and change over to that new directory that it creates for us automatically. And inside of there, you'll see a license and a notice, and most importantly, the Node Exporter binary. That's it. And so we can just run it. And once it runs on this system will be opening itself up to be scraped by the Prometheus server and share its Linux information. So let's run it. We'll do a /node exporter. And keep in mind, you want to make sure these binaries are set to executable. So you might have to chmod them, but normally if you download the binary, it should be already. And so we'll do a /node exporter, run it, and it is going. So it's listening, and we can see it's listening on addresses on port 9100 over here. All right, no TLS at this point. We're not using TLS in this lab. That makes it a lot more complicated, and it'll take a lot longer. But you do want to use TLS in the field. Anyhow, we now have this guy running. And let's open up a second terminal real quick here. And let's do a curl on this guy directly. We'll do an http://localhost 9100/metrics and see if it is properly exposing the metrics. We'll press enter. And yes, we see a big long list of metrics that it is exposing, and they all pop up in the terminal. So we know that it is working properly. At this point, the node exporter is working, but we have to tell the Prometheus server to look for that specific system. So we're going to do that. Now, this particular system, if I run an IPA, you'll see that the IP address on this system is 10.0.2.52. That is what I need to point to from the Prometheus server. So let's jump over to that server now and go back to the terminal. I'm actually going to stop this server for now. We'll press Control-C to stop the Prometheus server. And inside here, we'll go to the top of the screen. Inside here, we have Prometheus.yaml. So let's go ahead and configure that so that we can add that remote system. All right, so I'm going to do a vim on Prometheus.yaml. Now, often in the field, you'll see this file is going to be located somewhere else. It might be located in /etc/Prometheus or something similar to that. If that's the case, you would need to precede this command with sudo. All right. And by the way, you can use whatever editor you want. If you rather use Nano or gedit, if you're on a Linux system with the GUI, feel free. I like using Vim, so that's what I'm going to use. All right. So we'll do a vim on Prometheus.yaml. Now, this is broken down into sections. We have global config with our scrape intervals and evaluation intervals. We have the Alertmanager config, and then we have the scrape configs. That's what I'm interested in. Now, by default, Prometheus sets up jobs, and it automatically sets up a job called Prometheus. It actually scrapes itself, and the target for that is itself, localhost :9090. But what I want to do is I want to add the remote system. So I'm going to add a whole new job for that remote system and add it as a target. All right, so we're going to go to a new line here, and all this information is right in the lab. So you can just copy and paste that stuff over if you want, just to make it a lot simpler. And so here we have it. You want to make sure your naming conventions are correct and that your tabbing, your indentation is correct. But we have a new job name here, and it's called node. This is what I want. And then static configs and targets for that new job. This job will run independently of the job name Prometheus. Now, in the targets here, it says VM2 IP. Now, I don't know what your IP address is going to be, so I just left that there. But you're going to need to change that to the actual IP address of the remote system. Now, my server is 10.0.2.51, but that's already being scraped. And that's good for doing testing and checking out how the Prometheus server is doing. But my remote system is .52. So we want the IP address, or you could use the DNS name if you have name resolution working. But we'll use the IP address here, 10.0.2.52. That's my remote system, :9100. That's the port that is opened up by the node exporter. All right, and we'll save and quit. This looks good. So now we can start up our Prometheus server once again. If we go through the history here, we'll see our /Prometheus command and the Prometheus.yaml file. All right, let's press enter. That is now running. Very good. You'll notice a lot of stuff here. TSDB started, that's the time series database. The file name for the configuration is prometheus.yaml. And the server's ready to receive web requests, starts up the rule manager, and so on and so on. So this is your live log right here. Let's jump back to our browser, and we'll refresh that because really it wasn't running for a while. And now let's take a look and see if it's in our targets. Now you can do that in a couple ways. You can go to http://localhost:9090/targets. And that'll bring you directly to this location right here, target health. Now we see we have two jobs. We have Prometheus, which is our Prometheus server at the localhost:9090. And then we have the new job that we just added, node, which is at 10.0.2.52:9100. Very good. So it is up. And we see that the state is up here. And that is good. If we see red or down, then we know that there is a problem. All right, so awesome work. Again, the correct answer was B, targets, localhost:9100. Now, we put localhost here, but really, in the real world, you'll have to specify the IP address of the system. If you're doing this all on one virtual machine, which is fine, you can run Prometheus in one terminal and you can run the node exporter in another terminal, then it would be localhost. But if you want to connect to remote systems, and normally you would have the IP address here like we did, or the DNS name. But the important part is that it's :9100. That's the port for node exporter. Again, 9090, that is Prometheus's server ports. It's not node exporter. 9093 is the Alertmanager ports, and 8080 is not a standard Prometheus ecosystem port at all, but you'll use that quite often for testing and for web apps and things like that. All right, good. So in my Prometheus PCA video course, you have access to a course repository that includes scripts that I wrote for you that install Prometheus and Node Exporter automatically and run them as services. So check out the course at the link in the description. Another question down, but those first two were easy. Let's dive a little bit deeper. Question 3. You want to query the current state of all scrape targets in Prometheus. Which PromQL expression returns a value of 1 for targets that are up and 0 for targets that are down? A. Prometheus targets up. B. Node exporter up. C. Up. D. Scrape status. I'll give you 3 seconds now to pause the video, and I'll be back in a little bit with the correct answer. And the correct answer is C. It's just up. That's it. The up metric is automatically generated by Prometheus for every scrape target. 1 means the scrape succeeded. It is up. 0 means that it failed. You don't know necessarily if the target is down, but you do know that the scrape failed, and it's most likely that the target is down. Now, you can view this live in the web UI, or you can use the curl command, and we'll show both in the lab. The key element of the question is the current state of scrape targets. The current state, what is that? It's up or it's down. And it's a very simple metric. It's just up. That's all. So let's show this on the systems now. And I'm back at my Prometheus server. Let's make this a little bit bigger so you can see it a little bit better here. Okay, and I'm going to go back to the query option here. You have query, you have alerts, and you have status. That's your main 3 sections here within the web UI. So we're in the query section, and we enter our expressions right here. The most basic expression is up. And so if we type that and press enter, that'll show up there. And you can either click execute, or you can press enter again to execute it and show the results on the screen. So we see 2 results. We see the Prometheus localhost, the actual Prometheus server, is up. That's returning a 1. That's up. And we see the remote system 10.0.2.52, which is part of the job node that I created, and that is also up, another 1. So it's automatically running every version of the expression that it can find that it is tracking. Up is the metric, and then we have some labels here. For the Prometheus server, we have job equals Prometheus, we have instance equals localhost :9090, and then app equals Prometheus, which we're not really using right here. Then for the other version of the up metric, we have job equals node and instance equals 10.0.2.52 :9100. That's what we set up in the Prometheus.yaml. But we could modify this. We could say, okay, let's actually change how the metric works. And I'll say, okay, we'll use curly braces as our delimiters. And then you can start typing out all of the different labels that you want to work with. So I might type it, or I might do it automatically here. If you look at the settings in the web UI, you have autocomplete, and you have all types of information to make things easier for you here. I highly recommend you turn these on: autocomplete, syntax highlighting, the linter, and also query history, because you're going to be doing a lot of queries in here. So we'll do that, and we'll set up the curly braces, and I'll go down to job, and we'll say job equals, and in double quotes, we'll select what we want. Do we want Prometheus or do we want node? I just want node, what I created. And then we can comma separate those and do additional ones. And we'll say instance equals, and in double quotes, and we can pick the instance that we want. In this case, I want 10.0.2.52 :9100, my remote system. So that is the entire expression, including all the labels. If I do it this way and press enter, we'll just get the information for that one system. But if we were just to type up, it'll look at all the possible up metrics that are out there and all the possible systems that are up there, which is great because it's a good way to easily see what you have running in your Prometheus setup. Now, if we were to make a mistake here and do like another curly brace or something like that, it would be red. That's part of the linter. And the linter will tell you if you're making mistakes in your code. I might do something like some parentheses in here by accident, and it highlights those in red, and also it underlines the whole label in red. So I know there's a mistake there. Got to fix that before it'll actually work. Execute it again, and we get the same information. Or we could go back to just up and execute that, and we'll see all the systems that it's scraping against that it has access to, and see if they are up right now. Now you can also do this type of thing in the terminal, and let's open a second terminal here. And you can do that with, really, you could do this with any programming language that you want to use. It's very powerful in Prometheus. You can work with Python or Go or Ruby or Java or C or whatever. We're just going to do this in Bash with the curl command. And we'll do a curl, and in single quotes, we'll do http:// and we'll look for the local system. We'll say localhost :9090. Get myself out of here, :9090 / and we have to go to the API. Got to get into the application programmer's interface for Prometheus when we do this. So it's going to be /API/v1/query query again equals, and then whatever the expression is that you want. In this case, the most simplest of metrics and expressions, up. And then close out the single quotes. Press enter for that, and we'll get the JSON response, and we'll see all the systems that are up here. Now, why did I do localhost here? That's just because I'm querying the Prometheus server. I'm trying to find out from Prometheus itself with a PromQL query what is up. And it'll tell me that the local host, the Prometheus server itself, is up on job Prometheus. It'll tell me that the instance, the remote system with the node exporter on job node is up. But that's more machine readable stuff. If you want to make this a little bit easier to read, we could pipe that to JQ if you have that installed and run that. And now you can see it's a lot easier to read here. This is the last command that I just issued. And if we look down here, we see success. And we see Prometheus, the job Prometheus at localhost 9090, and 1 for up. And the same for the other system, the remote system, in the job node, also up. Now that was with JQ. If you don't have JQ, you could do a sudo apt install JQ and grab that. You could also use various Python methods to make it more human readable if you wish. Excellent. So up was the simple answer. Now, the other answers, Prometheus targets up. That's not a real Prometheus metric. However, it uses the right naming convention. It uses underscores in between each word, which is something you want to keep in mind, but not an actual metric that you would use. Node exporter up, no, that's not a real metric. Node exporter status is just reflected with the up metric, but in our case with the label job equals node. By the way, those labels are just key value pairs. Everything that you're seeing here as far as connecting to the API, working with key value pairs or labels, it's very common stuff in the DevOps world, and it's very standardized as well. And then scrape status, not a valid PromQL expression. All right. So in reality, I said, let's get a little deeper. We did get deeper into Prometheus, but the question itself was easy. As long as you do it in a hands-on manner, you will understand the questions thoroughly. So practice what you see on real systems. That's my suggestion to you. Question 4. You have installed Alertmanager and want Prometheus to forward firing alerts to it. Which section of Prometheus.yaml must be configured? A. Rule files. B. Scrape configs. C. Global. Or D. Alerting. 3 seconds to pause the video, and I'll be back with the correct answer. And the correct answer is D, alerting. The alerting section in Prometheus.yaml specifies where Prometheus sends firing alerts. It defines the Alert Manager address under Alert Managers. Rule_files defines where alert rules are stored, but without the alerting section, Prometheus has nowhere to actually send them. All right. So key elements of the question. The first is Alert Manager. We want to get alerted to things. And also section of Prometheus.yaml. Those are the key sections here. So let's get back to the lab. And I am back at prometheus.io/download. And what I want is the Alert Manager. And we want that for Linux once again. We have to install this. Now, this is another extension to Prometheus. So Prometheus is very extensible, as you can see here. The most common extensions are shown here, but there's tons more that you can work with. So we'll go to Alert Manager. We'll right-click Linux, copy link, jump over to our terminal, and let's grab that guy. We'll do a wget, paste in the link. All right. And now we should have Alert Manager. Let's untar that with the tar xvf on Alert Manager. Very good. Change over to that directory. And inside that, you will see license and notice. You'll also see the Alert Manager binary that we need to run. You'll see the alertmanager.yaml file for configuration and an AM tool, which allows you to analyze Alert Manager and how it works. All right, so that is now set up there. We're going to run it, and we're going to do that with just a /alertmanager. We could do that again. We could do that with the --config.file equals alertmanager.yaml, but it's going to know that by default. So I'm just going to run that. And it is now running. And if you look here, it says listening on, and it's port 9093, the default port for Alertmanager. Let's verify that it is indeed running. We'll go to our browser and open up a new tab here and go to http:// and we'll say localhost:9093. And indeed it is. And Alertmanager gets its own little web UI that's separate from the Prometheus web UI. You might not use this that often, but if you need to get deep into your alerts or do a lot of testing with your alerts, you'll go in here to work with your filters and your status and so on. All right, so it is working, but now to make it function properly, I have to configure Prometheus to send alerts to the Alertmanager. So we want to go back to our Prometheus.yaml. Let's jump over here. Now, first of all, we have the Alertmanager running in one terminal, and then we have the Prometheus server running in another. We're going to have to close out that Prometheus server. That's this one here. Okay, so we'll stop that with a Control-C, and let's modify the Prometheus.yaml. And once again, we'll do a vim on Prometheus.yaml. Okay, so we have to do a couple things here. First of all, we need to modify who the Alertmanager is. Let's scroll to the top here. Now, here's the Alertmanager configuration section, and it's known as alerting. And that's what we were saying here in the question. Which section of Prometheus.yaml must be configured? Alerting. So we'll go back to that. And we have an Alertmanager section, status configs, and targets. What targets are we alerting to with the Prometheus server? Well, there's none right now. It's just kind of commented out. So we're going to uncomment that. And we're going to say that this will be the local host, and we'll get rid of that, and we're going to say this will be the local host. So localhost:9093. Now you can put this in single quotes if you want, and you could also put that in curly braces here if you wanted to do that as well. So you have multiple options with this. You could put the targets in line-by-line fashion, or you could put them in curly braces and comma separate them. That's up to you. Either way will work. And, we could do it this way if we wanted to. We could say in square brackets, I might have said curly braces just then, but I meant square brackets when I was just mentioning these. And so if we have multiple targets, we could comma separate them or just do additional lines in the YAML file. Important part, know the IP address of the Alertmanager. It could be a remote system. In this case, it's running on the same computer as Prometheus. And also the port 9093. That is the default port for this Alertmanager system. Now, the second thing we have to modify is the rule files. If you don't have any rules, it's not going to do anything on your system. It's great to have an Alertmanager, but you need to have rules. So we're going to uncomment this, and you could use first_rules.yaml as long as you create the file and name it that. To stick with the lab, I'm going to use alert_rules.yaml. Stick with what I wrote here and use that name, and that is it. We don't have to change anything with what's being scraped. You just need to make sure you have an Alertmanager target, which is this local system, and a rule file to point to. All right, so we'll save and quit out of this. Good. And now I want to create that rules file. Now this could be, again, anywhere you want it to be, but I am going to place that here in the Prometheus directory. And the reason for that is because I didn't specify any kind of actual directory. This would normally just say, okay, if it's just a file name, we're just going to look where Prometheus is installed. Now in the field, I would specify a location for this and have it somewhere else, but we're doing this as basic testing and basic binary running of the programs. So we can do it right here. So I'm going to do a vim alert_rules.yaml. Okay. Create that new file, and we'll put in the alerts. Now I have some alerts in there. I have one alert actually in the lab, and you could just copy and paste that right in if you want to. All right, here it is. So you can have multiple groups And within each of those groups, you can have different rules. And we can name these. So I have a name, basic alerts. And then you have your individual rules inside there. The first alert, or which is a type of rule, by the way, is target down. And then the most important part is the expression, which is abbreviated to EXPR. So the expression is up $0. If and only if we get a result of 0 when we scrape a remote system or some system and it says 0, then that will be considered down. It won't be up. And what will happen is the alert manager will fire an alarm after 1 minute, because we're waiting for 1 minute. And it'll be a critical alarm, and it'll be accompanied by a summary target, and whatever the instance is, which is a variable here, is down. And that'll show up in whatever system we're sending this to, like PagerDuty. Okay, so that's it. That's a basic alert. We're going to save and quit this, and we'll restart Prometheus with a /Prometheus. That is now running, and we can go and check the rules and the alerts. Let's go ahead and do that. Okay, so I'm back at my web UI here, and if we go to alerts, we'll see the basic alert we just created, alert_rules.yaml, target down. Right now it's green. That means it's inactive. Green is basically good. There is nothing that is down just yet. So that is the actual alert. We can also go to status and go to rule health and see the health of the rules that we've written if there's any issues there. All right. You can also use the AM tool to verify the health of your rules. But I want to go into alerts here. And to test it, we'll go to our node exporter and we'll stop that node exporter on the other system. So let's go over to our secondary system here. We have 2 terminals open, and we'll press Control-C to stop the node exporter. Now, if we had also shut down the virtual machine, we'd get the same effect. But one way or another, if the node exporter is not open on port 9100, then it should fire the alerts. All right, so I'm going to wait 1 minute and fast forward through, because it's going to take 1 minute as we showed in the rule. Okay, and I've actually waited about 30 seconds, and we do have pending. We have a pending target down for this alert on instance 10.0.2.52. Give that another 30 seconds. And now we see target is down. It is firing. So it took a minute. And also, by the way, you might also see inactive. If you create the rule or the alerts and you jump right into the web UI, you might see it as grayed out and inactive until it's actually running the Prometheus server for a little bit. So you might see that as well. But we saw that pending, and that's because the Prometheus server scrapes every 15 seconds. And so it knows something is up, but it's not sure because it's going to wait for 1 minute. That's what we said in the rule, just in case there's some type of, configuration that's going on that remote system, and it'll be back up in 10 or 15 seconds. So it waits 1 whole minute, and you could do 2 minutes or 5 minutes, whatever you want, but then it actually fires. And so now we see it is firing. And it says alert name, target down, 10.0.2.52 on :9100. It's critical. It's firing. And that's been active for a minute. It's been down for a minute. All right. Very good. Let's bring that guy back up. We'll run the node exporter again. Okay. And within 15 seconds, we should see that it is back up. And we'll refresh that web UI on our Prometheus server. And we'll pause for 15 seconds here. I'll fast forward through that. And now it's green again. So it's inactive. We have no remote systems that are down. And so that is good. That is now fixed. Okay, incorrect answers here. Rule_files, that's a real location. That specifies the location of the alerting rule files, like what we created, alert_rules.yaml. but it does not configure the Alertmanager connection. And then scrape_configs, that defines the scrape targets and, whatever that scrape config is, the remote systems that we have the node exporter running on, but it's not alerting destinations. And then global, that sets global defaults like the scrape interval and the evaluation interval. And generally, the Prometheus system will scrape every 15 seconds by default. You could increase or decrease that, but you want to be very careful when you do so. All right, so alerting is a big part of the Prometheus exam and a very important part of working with Prometheus in the field. In my video course, I get very in-depth with it. We spend a whole big lesson on how to work with the Alertmanager, how to set up alerts, and configure the Alertmanager and Prometheus to send alerts via PagerDuty. So great work. That is question 4. And finally, question 5. You want to calculate the per second CPU usage rate for a specific instance, server 01, over the last 5 minutes, excluding idle CPU time. Which expression is correct? A, and we have a rate function. I'm not going to read through the entire thing. Or B, another rate function. C, sum and rate functions. Or D, an average function. This time I'll give you 5 seconds to pause the video and take your time, look through the question and look through the answers, and I'll be back with the correct answer in a little bit. And the correct answer is C, sum and rate. We're using both of those functions to figure out what we need here. By using sum and also rate and the mode != idle label filter, that way we can correctly aggregate all non-idle CPU states for a specific instance, in this case, server 01, and do that over a 5-minute range. And we see that here. So this is the standard pattern for calculating actual CPU usage with node exporter metrics, right? I'm excluding idle because I don't care about CPU idle. That means that portion of the CPU is not doing anything, right? All I care about is what the CPU is really doing. Hands-on alert here. Know your functions. Practice them in a hands-on fashion. And we'll do a little bit here, but I do a whole lot more in my video course. So key elements in the question: per second is 1. We want to see per second CPU usage and excluding idle CPU time. That's what we really want here. So this is really a rate function that shows CPU information. It's a CPU metric here called node_CPU_seconds_total. And then we just have a label, instance = server 01, or whatever remote system you want to find out more about. And then part of that is another label, mode ! equals, and in double quotes, idle. Exclamation point normally in programming means that we're omitting whatever is going to be after it. So we're omitting all the idle information. We're ignoring that. And then in square brackets, we have 5 minutes. So that's our range vector. That is the time frame for this. And then that whole thing is wrapped in sum. So it's going to sum all of this together for that instance for all modes except idle. There you go. So let's show this expression in the Prom Web UI. Okay, and we're back in the Prom Web UI here. We're in alerts from before. We'll go to query, get to our expression builder. And to start, let's just show rate. Let's show the rate function. And you'll see that we have a couple options here. Rate is indeed a function that you'll work with. And normally functions will have parentheses that will work in here. So it's going to be rate, and then we want to know what the metric is we're working with. That's going to be node_CPU seconds total. And I can arrow down to that. This specific metric is known as a counter, and you have counters and gauges. I talk about all that in the video course. But this is a counter. It's going to count how much information it can grab. What is the total, basically? So we'll press enter for that. Node CPU seconds total. And then in curly braces, those are my delimiters for my labels. So I'm going to say instance equals, and in double quotes, I'm going to do my remote system. So we'll say 10.0.2.52:9100. Now you'll notice that the entire expression and the label is underlined. The linter doesn't like this so far, and that's because we don't have enough information and we need to close it out properly, especially if we're using rate as a function. All right, so we do have everything in curly braces. That's really the only function I need. But then we're going to specify the time frame, which is 5 minutes. And we do that in square brackets. So in square brackets, I'm going to say 5M and close it out. Now it's not red underlined anymore, and it should function. Let's press enter, and that executes. And this will show all of the CPU portions, like IRQ and nice and soft IRQ, steel, and idle. Do we want the mode idle? No, we don't. So we can modify this and we can change it. And effectively, we can take everything here and put it into a sum. And we can sum all these different modes together. I don't want to see them individually for the most part, unless I'm really going deep into troubleshooting. So we'll do a sum and create another parentheses here and wrap this entire thing. And we have to have a second set of parentheses because we have two functions here. We have rate and we have the parentheses for that. And then we have sum and the parentheses for that. And if you ever get confused when you have multiple functions, just highlight with your arrow key or with the mouse, highlight the delimiter in question. So right now I'm highlighting the square bracket, it shows both. If I highlight the next to the right, that parentheses, it shows both. It shows it here and it shows it here. If I highlight the next one, it shows both of those, right? One other thing, I want to have one additional label inside my curly braces. So we'll comma separate that, and I want it to be mode. Mode exclamation point equals, and we'll say that's going to be idle because I want to exclude that. Very good. So effectively, this is what we showed as the correct answer in the quiz question. Fantastic. Let's run it. All right, there we go. And we see it, and the total here at 0.006. So not much happening with this remote system. Now, you could make the system busy and you could make it do all kinds of stuff, and that number will increase, but this is just one basic example. And you could also break it down by CPU mode if you wanted to, and I have a expression in the lab for that if you want to do that. All right, so that is it. This works, and you see some kind of advanced PromQL actually that's utilizing multiple functions, also working with multiple sets of parentheses because we have multiple functions, curly braces and square brackets. So all the delimiters, multiple labels. So this is pretty good. All right, so great work there. Let's look at the incorrect answers. If we look at answer A, that's just a rate. That's going to return rate for all CPU modes, including idle, because it doesn't have this, this much needed label here. And that's going to overstate the actual usage because of that, but it's going to show them all separately as well. B is incorrect because this will return only the idle CPU rates. And plus it doesn't have the sum to sum everything together. It doesn't matter because here this label says mode equals idle. We're not omitting it. We're showing only that one. And so we want that exclamation point in there. And finally, average, that's a different function altogether. If you use average when it's applied to a range vector without rate, without the rate function, it's not going to be a valid expression for counter metrics like node CPU seconds total. So by itself, it's not going to work. We would have to combine that with rates. All right, excellent. If you completed the lab, great work. Double thumbs up. If not, go and discover Fire. Go discover Prometheus. Clone the repo and get cracking. Well, that's it. If you liked the content, then please like the video and subscribe to my channel. And don't forget, your free Prometheus Cram Sheet and 5-question quiz is waiting for you in the description. To become a Prometheus master, check out my Prometheus PCA video course on O'Reilly, and the link for that is also in the description. So that's it. I'm Dave, signing off. Until next time, thanks for watching.